everyone, it's me again, and today I want to tell you about the topic how we see color. I promise you it's a very interesting topic, so let's get started. You might have heard that light is a kind of wave and that the color of an object is related to the frequency of light waves its reflex. High frequency light waves look violet, low frequency light waves look red, and in between frequencies light waves look green, yellow, orange, and so on. You may call this idea physical colors because it says that the color is physical property of light wave of light itself. And while this isn't wrong, it isn't quite the whole story either. For instance, you might have seen this picture before. As you can see, the region where the red and green lights overlap is yellow. When you think about it, it's pretty weird because light is a wave and two different kinds of frequencies should not interact with each other at all. They should just coexist like singers singing in harmony. So in this yellow-looking region, two different kinds of light waves are present. One with the red frequency and one with the green frequency. There is no yellow light present at all. So how come to this region where the red and green lights mix looks yellow to us? To understand this, you have to understand a little bit about biology, in particular about how humans see color. Light perception happens in a paper-thin layer of the cells called the retina, covers the back of your eyeball. In the retina, there are two different kinds of light detecting cells, rods and cones. The rods are used to seeing in the low light conditions, and there is only one kind of those. The cones however, are a different story. There are three kinds of cone cells that roughly correspond to the colors red, blue, and green. When you see a color, each cone sends its own distinct signal to the brain. For example, suppose to that yellow light, that is real yellow light, and with a yellow frequency is shining on your eye. You don't have a cone specifically for detecting yellow, but yellow is kind of close to red and also is kind of close to green. So both the red and green cones will get activated, and each cone will send a signal to your brain saying so. Of course, there is another way to activate the red cones and green cones simultaneously. If both red cones and red light and green light are present at the same time, the point is your brain receives the same signal regardless of whether you see light that has the yellow frequency or light that is a mixture of the green and red frequencies. That's why for light that's plus green equals yellow. So how come you can't detect the colors when it's dark? Well, the blood cells in the retina take over in low light conditions. You just have only one kind of rod cells, so there is one type of signal can get sent to your brain, light or low light. Having only one kind of light detector doesn't leave any room for seeing color. There are infinitely many different physical colors, but because we only have three kinds of cones, the brain can be tricked into thinking it's seeing any colors by carefully adding together the right combination of three colors, red, blue, and green. This property of human vision is really useful in the real world. For example, TV manufacturing, instead of having to put infinitely many colors in your TV set to simulate the real world, TV manufacturers only have to put 3, red, green, blue, which is lucky for them, really. So, thank you for your listening. Have a good time. Goodbye.